Hi guys, so in this video, I'm going to give kind of a drastic overview of encephalitis and meningitis. And then at the end of this video, we're actually going to focus a bit on bacterial meningitis. I don't really have a separate video that goes over each of the bacterial meningitis. In this kind of module, I think I go through like Neisseria meningitidis and group B strep. That's not to say that there aren't other organisms that cause bacterial meningitis. In fact, the most common one in adults is Streptococcus pneumoniae. But the reason that I'm doing it this way is one, you guys have already learned about a lot of them. If you go through, the videos that you've already watched on my YouTube channel, or you go through any of the cases that we learned about in host defense, host response, we've learned about a lot of these organisms. So this video is a little bit more of an overview where that's concerned. Also, we're going to kind of lay some groundwork for some definitions that I'm going to use in kind of this series of CNS videos, okay?
All right, so when we talk about CNS infections, you're really thinking of three things, and actually kind of the most important thing I have listed here at number 3, and that's location. And the reason I have it listed last is that we're going to go into far more detail about that. So you're going to think about where it is. It is in the actual like brain parenchyma, or is it in the meninges, or is it a localized infection like an abscess or throughout? So we'll go into that in more detail. The kind of other thing you think about is what's causing it. So what's the agent? Are we dealing with like a bacterial meningitis, which is also sometimes known as septic, or are we dealing with a viral, which is often known as aseptic? Or is it something kind of a little more uncommon, like a parasite or a fungi? And this is actually a really important distinction and something that we're going to spend a lot of time on in this video and also in your class session, is really being able to, from a CSF profile, get an idea as to what class of organism you're dealing with. And the reason for this is actually very specific and important. Bacterial meningitis tends to be a lot more severe, but we can treat it. We have antibiotics. Viral meningitis, we can't really treat that many of them. Really, the only one that has kind of a reliable treatment is HSV, but it's okay because it tends not to be as fulminant. Parasitic and fungal CNS infections are kind of their own realm. There are treatments for many of them, but these are kind of the two distinctions. Um, okay, and then lastly, we're going to talk about immune status. So immune status always plays a role whenever we're thinking about infection. So you're going to think of kind of your big question. Does my patient have a good immune status, or are they potentially immunocompromised? So if they're HIV positive, you automatically know they're immune compromised. And HIV is actually kind of a huge risk factor for some of these fungal and parasitic infections, although those can occur in immunocompetent individuals as well. And the other thing is age, right? Because for our very young patients and our somewhat older patients, that also plays a role in their immune status. Okay, so let's talk about that all important number 3 bullet point on the last slide. Location, location, location. Just like real estate, this is so important when dealing with a brain infection. So the first thing we're just going to kind of touch on briefly is, how did it get there? How did the organism get there? And just like other parts of the body, we're really dealing with kind of two methods. We're talking about hematogenic spread, and we're talking about local extension, right? So if we're thinking about local extension, we're thinking about an infection that the first time kind of primary infection was somewhere nearby, okay? The sinuses is a great example of this. Scalp, inner ear, so you have like a bad ear infection that leads to bacterial meningitis. And that's actually something to kind of keep in mind. Babies get ear infections all the time. Parents notice them and they bring their kid in. Adults get ear infections and think, oh, that's silly, and don't necessarily come in right away. And it can actually be a little bit of a risk factor. So we want to keep that in mind. Hematogenous spread, we're talking about any time a patient has some sort of septicemia or viremia or parasitemia, fungemia, but really we're talking about it's in the bloodstream, right? We're talking about a systemic infection. So not just like localized in one area nearby, but an actual systemic infection. So that's how it gets in. But once it gets in, what we're really talking about when we talk about meningitis versus encephalitis is where is the inflammation? So you have this organism, but where is it actually causing inflammation? And if it's occurring, is it widespread or is it localized? Because there are a couple options when considering location on kind of a more global scale, okay? So meningitis, this is inflammation or infection of the membranes that surround the brain and spinal cord, i.e., your meninges. And this is largely going to occur in the subarachnoid space, okay? So you got your dura here, your pia here, the arachnoid here. So we're talking about kind of in this area around here, this subarachnoid space. That's where we're seeing the inflammation. That's where you get the infiltrate, and it's actually the infiltrate that's actually leading to the symptoms most of the time. This differs from encephalitis. With encephalitis, we're actually going to see infection of the brain parenchyma and inflammation of the brain as well. And that's not good, right? Because the brain has this hard skull material. And that basically does not mean we want our brain swelling, right? Because it's going to come up against it's between a rock and a hard place. It's coming up against the skull. So that's not good. Meningoencephalitis. Everybody gets to play. That means we've got infection and inflammation, not just in the brain parenchyma, but also in that subarachnoid space again. There is kind of one other option, and those are abscesses. These are kind of localized infections within the brain parenchyma, so you can see that here. This often will have kind of like a fibrous capsule, and that's what I'm showing there. You can get an abscess in your brain just like you can on your foot. It's just localized to one spot. It's not the whole thing. Same thing with the brain. Okay, so let's talk about bacterial meningitis. Like I said at the beginning of this video, I'm not going to talk about most of these organisms kind of in the way you're used to hearing me talk about them. And that's because they have their own specialized videos or we've already covered them. So really what we're talking about here is kind of like the pathophysiology and some of the etiologies behind bacterial meningitis and what bacterial meningitis is. Just because I don't mention it in this video, that doesn't mean it can't cause bacterial meningitis. Like, I don't specifically call out E. coli, but E. coli is pretty much the gram-negative bacilli that I'm referring to here. There is a whole video on all of the E. colis that you can watch that we actually, if you're a Rush student, we talked about in your Jenna Wilson case. So organisms of every type could be involved here, but we're going to focus on a couple. All right, so first off, bacterial meningitis. This is a medical emergency. You are not going to wait to treat this patient. You are going to begin empiric treatment right away. You don't wait around for PCR or CSF lumbar puncture culture or blood culture to come back positive. No, 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 no. That takes way too long. Every hour that passes, you have the possibility of completing another replication cycle in that inoculum or pathogen pool. So we're going to start with empiric treatment. So what are our empiric treatments for bacterial meningitis? Currently, it's vancomycin plus ceftriaxone for everyone under the age of 50. If we go above the age of 50, we need to keep an eye out for this one, right? Listeria monocytogenes. So if you've recently had an outbreak nearby, or you've got somebody who's in an immune protected status or an immunocompromised status where you're worried about listeria, you're going to add in ampicillin to cover for listeria. But otherwise, Vanc-Ncef is a good place to start because that's going to cover a lot of these bad guys. So what you're going to do is you're going to get that lumbar puncture, you're going to get the blood, you're immediately going to put the patient on empiric therapy before you get the results back. When you get the results back, you can adjust your treatment plan, but we're not going to wait. One of the ways we can tell kind of early on, before any of the gram stains or cultures or anything comes back, if a patient might have bacterial meningitis is actually the CSF profile. So bacterial meningitis has kind of its own signature in your CSF. We're going to see a lot of cells, and particularly those cells are going to be neutrophils, polymorphonuclear cells, PMNs, however you want to refer to them. Why? That makes sense. Neutrophils eat bacteria, so they're showing up at the buffet. So you're going to see a lot of them in the CSF, greater than 100 cells per microliter, with almost 90% of them being PMNs. Your protein is going to be a bit elevated, so it's going to be greater than about 50 milligrams per deciliter, and the glucose is going to go down, so less than 40. So when you see that signature, high neutrophils, high protein, low glucose, you're definitely thinking bacterial meningitis. You just don't know what the agent is yet. You're going to have to wait. But you can make some guesses. We can make some really educated guesses here, and that's because there are definite trends, okay? So if your patient is less than a month old, for the most part, you're looking at group B strep, strep A galactiae. Patients can technically get group B strep up to about 3 months old, and that's kind of late onset. But early on, 50% of those cases are going to be group B strep. The other kind of significant minority here, like I said, is those gram-negative bacilli, and really I mean E. coli there. It might be something else, but largely we're talking E. coli. And then you kind of have a handful from these other ones. H. flu, if they're pre-vaccination site, Neisseria meningitidis, specifically if they're like had some sort of exposure recently, and Listeria if they've had exposure, particularly in utero. Once they get above that 1 month mark, we actually kind of treat them the same way we treat many of you who are probably watching this video. They're in kind of that same pool where we worry about 2 organisms more than anything, Neisseria meningitidis and Streptococcus pneumoniae. In younger people, pretty much the cause of bacterial meningitis more often than not is Neisseria meningitidis. As patients age, the cause more often becomes Streptococcus pneumoniae. So you see here, you've got kind of this skewing where early on it's Neisseria, and then later on it's more likely to be strep pneumo. So those are kind of your big hitters, right? If they're really young, let's think GBS and E. coli. Once they get past that, 1 month period, it's probably Neisseria. If not, it's probably strep pneumo. Once they get over 30, it's probably strep pneumo, if not Neisseria. So kind of a good way to kind of narrow your field down. Okay, I know I'm not a pathologist, but I used to give kind of the neuropath lecture. So just kind of giving kind of an orientation here. When we're talking about bacterial meningitis, on gross examination, you're going to see kind of this yellow-green pus that surrounds the brain, okay? So you can actually see here at the number 1 that you've got kind of like the meninges that are pulling away, that are showing the cortex here. And that gives you the idea of kind of the different color of the meninges to the gyrus. And that show and then you can also see down here that like the meninges are full of pus down here, just showing kind of that suppurative process that we've come to expect from bacterial infections. Okay, so the nice thing is that pathology basically mirrors the inflammatory response. So when we've got inflammation of the meninges, so when we see this inflammatory response, what happens is we actually compromise the arterial supply or the venous return. And that basically leads to ischemia and edema of the brain parenchyma. So as the brain parenchyma continues to swell with all of the edema, the intracranial pressure increases, and that's actually going to further compromise the blood flow as well as the brain parenchyma. So it's just kind of this forward-feeding cycle. So this is what leads to that long-term sequelae that's due to kind of these ischemic brain lesions. Okay, so now that we know what bacterial meningitis is, we're going to focus on some examples of it. Particularly, I don't really go into them in detail in the notes because we've talked about one of them a lot and one not so much, but Mycobacterium tuberculosis we've discussed before. This is kind of one of those atypical bacteria. Remember, we're talking about those acid-fast rods. It can cause meningitis. And it actually causes a very specific type of meningitis. It causes a bacillar meningitis, basically a meningitis that is taking place around the base of your brain. So basically when TB causes meningitis, you get these tuberculomas within the brain parenchyma, and these focal lesions are granulomas within the brain, and they're made primarily of these multinucleated giant cells. And if you look in the course notes, I've got a nice pus-filled picture of bacillar meningitis. T. pallidum, this is actually the causative agent of syphilis. We're going to cover this more when we talk about the rest of the STIs. But syphilis actually causes a neurosyphilis in some patients. We don't tend to see it as much anymore. There was a real rash of it for a while. Haha, get it? Rash. Anyway. for a while in the US historically, but it has not kind of been a huge concern now. But there are certainly neurologic sequelae that are associated with basically syphilis infections. So stay tuned for that later. So with meningitis, keep in mind we're talking about your location, the agents, and the agents could be any of those organisms that we've already talked about, and the immune status of the patient.